With this list of numbers, how might you guess the number I'm thinking of? Well, maybe you start guessing randomly. Or perhaps you said, I'll guess one at a time, like so. By the way, this is called linear search. Oh, looks like you got the number. Well, of course you did. These are both possible ways of guessing the number. Okay, now, can you guess the number I'm thinking of out of all of these? Well, guessing randomly or incrementally, those will be too slow on this list. So, what if I said, let's play higher or lower? And this is basically what binary search does. It uses a sorted list and plays higher or lower with it. Okay, so now let's see it in action. Let's say we want to find the number 57. So we choose the middle value, which is 50. We check if it's the target. No, 50 is not equal to 57. Now we check, is it higher or lower? Well, our target value is higher than 50, so we can eliminate all the numbers below and including 50. Now we get the next middle value, which would be 75. We check again. We repeat until we have found the value. There are multiple ways to implement binary search, either recursively or with a while loop. We'll use a while loop in Python. First, define a function that takes in an array and a target value. Next, initialize two variables, low and high, to track the search range. Since they represent an index, high should be -1. The while loop continues as long as low is less than or equal to high. If low becomes greater than high, the target value is not in the array. Inside the loop, calculate the midpoint of the current range. Using conditional statements to compare the midpoint value with the target, if the target is larger, move low to mid +1. If the target is smaller, move high to mid -1. If it matches, return the midpoint index. If the loop ends without finding the target, return -1. Finally, define an array and a target value, call the function, and print the returned index if the target is found. Let's see it in action. We want to find the number 44. Remember, the list must be sorted. Let's see how many operations it takes to find one out of a list of 100 numbers. Remember, we have to list each iteration. Okay, so worst it takes is 7 operations. That's pretty quick. Let's see a table of linear versus binary search for worst case of operations. Remember, linear search looks at every item in a list. Binary search can be described as O of log n, where n is the number of items. Let's say each operation takes 1 millisecond. To check 1 million items, binary search takes 20 milliseconds, whereas linear search takes 1 million milliseconds. Let's convert that to minutes. Yikes. That's approximately 17 minutes. Just to find a number? Good thing we learned binary search.